Welcome to Daily AI and Machine Learning Lessons. I'm Blake.
And I'm Jude. This is the Deep Dive, where we unpack complex ideas to give you the insights you need fast.
It's something we see all the time. Someone builds this apparently great model, but then it just tanks in the real world.
Hmm.
And often the problem isn't some super complex algorithm thing. It's actually right at the start, how you split your data.
Exactly. So today, we're going to dive into that. Effectively splitting your data set. It sounds basic, but getting it right is just, well, crucial for building models that actually work.
Right. So when we talk splits, we're usually talking three main parts.
That's right. The training set, the validation set, and the test set. Each one has a really distinct job to do.
Okay, I think most folks listening get the basics, but can you maybe quickly hit on the specific challenge each one solves for us?
Sure thing. So the training set, that's the bulk of your data, right? It's where the model does its learning, finds the patterns. Think of it like the textbook.
Got it. The
Yeah,
learning material.
precisely. Then you've got the validation set. This is more like your practice problems during the course. You use it while you're building the model.
For tuning things, like those hyperparameters.
Exactly. Tuning hyperparameters, checking performance as you go, and critically making sure you're not just memorizing the training data, overfitting.
Okay, makes sense. And the last one, the test set.
That's the final exam. It's data the model has never seen before. You only use it right at the end for that final, unbiased grade on how well it generalizes.
The real world check.
That's the one. It tells you how well it's likely to perform out there.
So, given how important these are, what's the magic ratio? I hear 80/20 thrown around a lot. Is that like the rule?
The 80/20.
Yeah.
It's a very common starting point, yeah. Often people take 20% off the top for testing.
Okay.
And then from the 80% left, maybe take another 20% of that for validation. So that works out to 64% train, 16% validation, 20% test.
Right, I've seen that breakdown, or sometimes just 6-20-20.
Yep. Andrew Ng talks about 60-20-20 a lot, too. It's in that ballpark. Kind of aligns with that Pareto idea you see elsewhere. Focus most effort on training, but reserve decent chunks for checking.
But does that hold up if you've got like a massive data set, say 1 million records instead of a few thousand? Do you still chop off 20% for testing?
And that's where it gets really interesting. And the answer is probably not. Those percentages are good rules of thumb, but the ideal split, it really depends on the data set and the problem.
How so?
Well, think about it. If you have 1 million examples, even a tiny percentage is still a lot of data points. Maybe you only need, say, 0.5% for validation and 0.5% for testing.
0.5%. That sounds incredibly small.
It does sound small percentage-wise, but 0.5% of 1 million is 5,000 examples, right?
Okay, I see. The absolute number matters more than the percentage at that scale.
Exactly. 5,000 or maybe 10,000 examples in your validation and test sets might be more than enough to get a reliable estimate of performance to capture the data's variance.
So you don't need to sacrifice a huge chunk of potential training data
Yeah.
just to hit a percentage target.
Precisely. You get reliable evaluation without hamstringing the training too much. Now, if you had a tiny data set, like 100 points, then you'd need something else, like cross-validation. Simple splits wouldn't work well there.
Right. So this all points to why we obsess over these splits, doesn't it? What's the core tension we're balancing here?
It really comes down to variance. Two kinds, actually. If your training set is too small, your model itself might be unstable. Its parameters might have high variance. It might just learn noise.
Okay, bad model.
Yeah. But if your test set is too small, your evaluation of the model will have high variance. You won't be able to trust the performance score you get. Is it really good? Or did you just get lucky with a tiny, unrepresentative test set?
So it's this balancing act. Enough data to train reliably and enough data to test reliably.
You've got it. Finding that sweet spot so you can trust both the learning process and the final score. The whole point is figuring out how the model will do on new data it hasn't seen. And there's even research suggesting, that the validation set size should relate to how complex your model is, how many parameters it can tweak. More complex models might need bigger validation sets.
Interesting. So practically speaking, how do people actually do this splitting? Is it just random sampling?
Usually, yeah, it involves random sampling. Often you'll use a function, maybe from a library like scikit-learn, and apply it twice.
Twice. How does that work?
Well, first you might split off the test set from the whole data set. So you have, say, training plus validation and the test set.
Okay, lock the test set away.
Right. Then you take that remaining chunk, the training plus validation part, and split it again to create the actual training set and the validation set.
I see. A two-step process.
Yep. And it's really important to make sure it's random, but also sometimes you need stratified sampling.
Stratified. What's that?
That means making sure the proportion of your target classes, like, say, fraud versus non-fraud cases, is the same across your training, validation, and test sets.
Ah, so if 5% of your data is fraud, you want 5% fraud in each split.
Exactly. Crucial for imbalanced data sets. Otherwise, your test set might accidentally miss a rare but important class, giving you a totally misleading evaluation.
Wow, okay. It really shows how something that seems so simple, just dividing up data, has all these layers of complexity and directly hits model reliability.
It absolutely does. It's a fundamental piece. Understanding these nuances, it's key to really getting good at machine learning. It's not just fancy algorithms.
It's about knowing your data and how to prepare it properly. A really important reminder.
Couldn't agree more.
That's all for now, folks. Please like, share, and subscribe to help fund this channel.